Hello everyone. Today is the 21st day of Leetcode 75 challenge. Let's begin with the 21st question. Question 1207. Unique number occurrences. The level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. Right? So you are given a list of numbers and some numbers may appear more than once. Fine. So there could be a list of numbers and a number can appear more than once. So this is the thing. It's appearing two times. So the question is asking, do all numbers appear a different number of times? Okay. If yes, return true. If any two numbers appear the same number of times, return false. Basically, 1 comma 1 appears two times, correct? Then 2 comma 2 comma 2 appears three times. Okay, fine. So this line states this thing. Do all numbers appear a different number of times? Yes. One appear two times and two appears three times. So true. But if like 1 comma 1, 2 comma 2 appears two times and two times, if any two numbers appears the same number of times, return false. They appear since same number of times, so we will return false. So this is just a simple question, and I hope you understood this explanation. Let's understand the constraints. The length of the array could be from 1 to 1000, and value could be from minus negative 1000 to positive 1000. Fine. I hope you understood the problem explanation and constraints. Now let's move to the next slide. Let's understand the input output of the problem. Okay, so here you can see one is there, 2 comma 2, 1 comma 1 comma 3. So you can see that one appears three times, two appears two times, and three appears one time. All the values or all the counts of each digits are different. Therefore, the output is true. Fine. In this case, one appears one time, two appears one time. So this counts of both one and two are same. That's why we return false. So this is the input output explanation. I hope you understood it. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Right? Imagine you are organizing a school event where students drop their favorite color slips into a box. Fine. And some students pick the same color, like five kids choose blue and three go for red and five more pick green. Okay. Now your teacher comes to you with a fun challenge. So we are trying to build up an intuition with a story here, fine, so that the question is crystal clear to us what it's asking, fine. So what's the challenge is given by the teacher? It's given that let's see if every color got a different number of votes. No ties allowed, right? This is what basically our question is asking, which means that if blue got five votes, no other color should have five exactly, right? If red got three votes, then number should be unique too, and every color's vote count must be different from others. Basically, if blue color appears five times and red appears three times, then green cannot appear five or three times. It should be either less than five or greater than three or just greater than five. Got it? So this is the fun task given by the teacher, and this also resonates with our question. So what we can do in this case? First of all, the count has to be unique. Okay, keep in mind. Foremost thing, the count of every slip should be unique. Okay. Second, is there any second thing we need to understand here? No, I guess, right? That's all. So for uniqueness, what we usually use, if you can recall, okay, let's keep that in on hold right now. Fine. One more thing you have to put in mind here is that we need to know the count of the slips, like blue slips, how many are there, right? So we will store it in some data structure like blue having count 5, red having count 2, right? This is the second thing we have to keep in mind, because without knowing the count, you cannot get the uniqueness for the number of times it appears, right? So this is the two important things we have to keep in mind. Now, okay, we got the intuition that okay, we need to store the count first of all, and the structure has to be something like this, that left hand side carries the name and right hand side carries the value, and then we need the uniqueness. Okay, so how we will do? First, we need to count how many times each color has was picked, right? It is like saying that let me note down the vote count for each color, right? Like for blue, we got 3. For that, we can use dictionary, right? To store the color as they and as their key and count as the value, right? I hope you got this point why we are using dictionary here. Because dictionary is a data structure which stores in the format of key value pairs, right? So if you can see here, we were storing how blue and the value, right? So this is the first thing we can say that we need to know the count, right? So similarly, it is right. It is something like writing in a slip that blue, which is key here, and value is 3. Great. So yeah, to store the count of the slips, we need dictionary, which basically represents that we need dictionary to store the count of the integers given in the array. Now we need to check for the uniqueness. If you can recall, we all know the data structure in Python, which stores the unique values in it. If you are not able to recall what it could be, we want to check if those counts are all different, right? Think of putting each count in a separate bucket and seeing if count repeats, right? It could be like there are multiple buckets and we are storing all the unique counts here. And if a count repeats, for example, here two count is there, two count is there, we spot a repeat case in that scenario, right? To avoid this, what data structure do we use? To do this quickly, we use set data structure because set is only the data structure in this case which keeps the unique values. Now, if the number of unique count, now this is done, right? Before going to this line, this is done. We have the count, we have the unique values also with us, right? Now what? Now we have to also keep in mind that how we will come to know that all the values which we got or the count which we got are unique. Keep in mind, in key value part in dictionary, key is always unique. For example, if you got blue one time and it was count 1, fine. Again, if you encounter blue, it will remain here and the count will move to 2, fine. And if you encounter new variable red, it will store here in the new row, you could say, fine. It's same in the case of set. That set, if it counters 2, fine. But if it encounters again one more 2, this 2 will get replaced and this new 2 will be stored here, fine. Okay, we understood that keys are always unique in dictionary and yeah, set always store the unique values. Now, for example, let me clear it more. Till now, we have resolved two things: how to store values for the count and how to get the unique values. Now, how we will check whether the that all the colors are unique or not. All the we can say that count of slips are unique or not, which is the final thing. Let this be a dictionary. Blue 5 times, red 3 times, green 5 times again, right? Then yellow 2 times. Now, what you thought? You got the count. Great. What is the size of the map or dictionary? It's 4. Now you thought of putting this count in set so that we get only unique counts with us. Fine. So you stored here 5. Then this is done. You stored 3. This is done. Again 5 came, right? But 5 is already in the set. So and assuming it gets deleted and new 5 gets entered, this is also done. Now 2 is there. Now these are the values in the set. What is the size of the set? 3. Oh, now you can see that map size was 4, but set size is 3, which means 4 is not equals to 3. So we will return false. because if in map or in dictionary, if this all the counts in the right hand side would have been unique, therefore the count in the set will also have been unique because set store unique values, right? Since two of the counts repeated here, which is 5 and 5, set will take only one 5, right? Because it takes unique. That's why the size reduces to 3, right? I hope you're understanding this part, why we are using set and dictionary here, right? So it's nothing complicated. If you take an example, like if you had all the unique values, like the blue, red, and green, 1, 2 in dictionary, and you store the count in set, it's 1, 2, and 3, right? Size of the set is 3, size of the dictionary is 3. Both are equal. So true, right? So this is a simple thing. You can see here also, if the number of unique counts is same as the number of colors, then we know all the counts were different and we return true. The question is simple as that. We need to know only about the data structures, dictionary, and set, because this question emphasizes on the learning of data structure, which is hashing, which includes basically dictionary and set. So we took a story, we understood the story in more easier way. We figure out that okay, we need uniqueness, we need a count, and after that, how to check all the counts of map is equals to the set or dictionary. Map could also be said as dictionary in Python, right? So I hope you understood the intuition and how we came up to the idea of using set and dictionary in this case. Now let's move to the next slide. Before going to the approach, let's understand what is dictionary data structure in Python. Fine. Dictionary in Python. A dictionary, also known as is a built-in data structure in Python that store key value pairs. The key is always unique and it allows fast retrievals, insertions, and deletion of data using keys. Fine. What are the properties of it? Stores data as key value pairs, like X has the count 2 or whatever the value of it is there. Then no duplicate keys are there. Keys must be immutable. It cannot be changed. Fine. Values can be of any data type, and it is accessible in typically of O of 1 average time due to the use of hashing in it. Fine. And why is it efficient? Fast lookup. On average time, we can just check the key in O of 1 time. Easy to store and update the data structure, right? Like if you just say here, like D is a dictionary. If you write here key equals to some value, so it gets updated, right? And highly optimized for associative data mapping, like counting the occurrences, grouping the data, mapping keys to values. Whenever you have to map something with something, like you have to store something about X, so you can use dictionary so that okay, we know the value is X, and whatever the related information with it is stored, it could be stored in value, right? Also, there are operations to it, multiple operations of dictionary. I've written the table here. So one is add and update. You can just add and update in this way, correct? Then accessing using the dictionary key, you can return the value of the given key. Safe access could also be done using this is a safe action. This means that returning a value or default if it is not found. Basically, in this case, if the value is not there, it will return some error or some garbage value, right? But in this case, you're putting default here that if you don't have the key, just return something other than the value, right? Remove, we just write delete del and the key there. That signified specified key. And similarly for safe also, it is something like that only. Accessing the keys, accessing the values. If you are using items, then in for loop, if you just write key value, like in for loop, if you write for key value in d dot items, so you could directly get items and values or keys and values through iteration. Right? Checking existence, if key is present in the dictionary or not, and look over items the way the one I described right now. This is the thing, right? So these are the most commonly used operations of dictionary, and this is enough operations to understand to complete all the data structures questions related to the dictionary. I hope you understood what is dictionary data structure and how it is used and what are the efficiency and key properties of it. Now let's move to the next slide. Before going to the approach, let's understand what is set data structure in depth. Okay, so a set is a built-in data structure in Python that stores unordered unique elements. Fine, these two things are important. It is particularly powerful when dealing with problems involving membership checks, duplicates removal, or mathematical set operations like union or intersections. Fine. Basically, if you do set one intersecting, set two, so you will get only elements which are common in both. Fine. And if you do, subtraction, so it will give the values which are present only in set one and or in set two. Fine. Now, what are the key properties of sets? There is no duplicate elements. First thing, fine, checked. It is unordered, no indexing or slashing. Checked. It is mutable, can add or remove elements. Fine. Supports standard set operations, which are here I will discuss with you. And why it is efficient. This is the important thing, right? Why we are using set in any of our DSA problems? Because testing is O of one average thanks to hashing. It takes only O of one time in average to do any application or operation of set. Eliminates duplicates automatically. Efficient. Useful in problems involving checking if elements repeat itself, basically duplicate element. Fast lookup whether this element exists in set or not, and comparing data sets. Fine. Now, what are the operations? Fine. Adding into the set, removing from the set, checking membership. Like if you go in add, right? So s dot add adds an element to the set. Fine. Remove s dot discard two. So removes if present. No error if missing. Basically, if two is present in set or not, right? Then remove it. Checking membership if three in s. Check if an element exists in a set or not. Fine. Union means what? S2 or S1. Okay. Any of the time. Union with S2. Fine. So if we have something values in set 1 and in set 2, and when you make the union of both of them, so it creates one big set of unique elements. Intersection is this common elements only, as I said, and difference, subtraction, items in S1 but are not in S2. Great. This is all about set data structure we should be knowing about for our solving any DSA problems. Okay, now let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach how we're going to solve it. So it's very simple. We will define a dictionary and count the occurrences first. Fine. So we initialize an empty dictionary. We keep it as name as map. In Python, if you write a variable name, whatever, and just initialize in this way, this also says that it is a dictionary. Fine. Then we loop through each number in the array, which we have to. The number already exists in the map, we increase its count by 1. Right? If x is there already of some count 1, and you appear, if you get that value in array again, you don't just remove and do the same stuff again. You just update the count to 2. If it does not exist, you will just enter it. Right? This one with the count 1 because one time we got it. This helps us to set up a track how many times and each number occurs, right? In the intuition, if you take how many times a particular color slipped they encountered, right? So this will help in storing the count for each integer in the array, right? Dictionary, key, and value. Now coming to the defining set and collecting the frequencies. Yeah, this is the important task. We know the count. Now we have to check that how many unique counts are there, right? So we don't do anything. We just initialize a set. Suppose you're looping and dictionary of key, right? So key dictionary of key means we get the value bit of it, right? We put it in set. So this will help us to add each frequency to the set. And since set gets only store unique values, any duplicate frequency will automatically be ignored, right? As we understood in our intuition also how it is done. So this is very simple. We just put the count in here so that we get only the unique counts which we have. Now compare the size of the set and dictionary. Length of set gives the count of unique frequencies, and length of map gives the count of unique members or numbers in the array, right? If both the lengths are equal, it means every number had different frequency, we return true. And if not, some numbers share same frequency and return false. Basically, let me repeat it again. If set has 2 and 3 and map has 2, 2 and 3, 2 appears 2 times, right? And might have different keys, but values are same. So this 2 will appear one time in set, right? Because it considers only unique values. So if there is a reduce of size in set, it automatically signifies that, okay, there may be or there is a confirmed idea that they are repeating values in map or dictionary, right? So we return false. If they are equal, we return true. So I hope you understood the approach. Now let's go to the next slide. Now, how hashing basically set and dictionary is helping us here. Let's understand it in a nutshell, how it is helping us in the question given. Taking out a quick frequency tracking, dictionary help us to count how many times numbers each appears just in one pass, fast and efficient, right? Easy duplicate detection using sets because as we put the values in the set, it removes the duplicates from it and instantly check if frequency repeats by comparing the lengths, which we do, right? Clean and optimal logic using hashing avoids nested loops and makes solution both readable and performant. So this is why using dictionary and set makes sense in this question. And we got to learn also about how set and dictionary is used and what is the concept behind it and what is hashing. Hashing is a big concept. We will learn about hashing in some other video. But for now, just understand set and dictionary. Okay. I hope you understood the approach and how we landed to the approach. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. So here we declare the dictionary. We look through the array. We're putting here key values. Basically, map of value means value of the array which we are right now encountering to 1. 1 means first time occurring. If it is already in map, we are incrementing it. That's all. Then we declare a set and we iterate over the map and we put the values in the set. So, right, and at the end we just compare their length. If it is equal, we return true, otherwise false. Now, time complexity comes out to be O of n here. Why? Because the length of the array is n, we will iterate n times. That is for sure. First iteration is done here for storing the values in dictionary and taking the count or taking the frequencies. Fine, O of n time. Then we iterate over the map again, which is O of n, right? And we set it id to the set. So it basically equals to O of n only. It's 2n, so it is converted to n. Fine. And why space complexity is O of n? Because first for dictionary, but there could be a chance that set could be less than n or equal to n, right? So, and for that, that's why the time complexity comes out to be n in this case, right? I hope you understood the code and its time complexity and space complexity. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Fine. Let's take this example and do the dry run. I will create here dictionary, key, and value. Fine. Okay. Now -3. We encountered -3 first. Count will be 1 according to our code. If it appears first time, as we wrote there, the map of value 1. In else case, we wrote this, right? And if case, we wrote if value in map, then we what we did map of let me rewrite the thing again. It's a bit unclear in this case. Thing was if value in map, correct? If it is map means dictionary. So what we did, map of val, we incremented it by 1. Else, if it is the first time, we just entered the value 1. That's all. So this is the first time. Now we went to 0. 0 also first time, increment the count. Add 1 there. Coming to 1. 1 also first time, add 1 here. Coming to 3, okay, 3 comes out to be again. So it is already in this map or dictionary. We increment the count to 2. Encounter 1 again, it's in the map or dictionary. Increment the count to 2. Again 1, it becomes 3, right? Again 1, it becomes 4. Again we encounter -3, it is in the map. So from 2, it becomes 3. 10 first time. So what? 0. We encountered 0 previously. So 0 is here. We remove this and we increase it to 2. So this is our dictionary right now. Okay, good. Next step was create a set. So let this be a set. 3 is entered here. 2 is entered here. Right. Then 4 comes. Then 1 comes. Right. So we have 1, 4, 2, 3 with us. Next step was taking the length. Length of dictionary is 4. Length of set is 4. Since both are equal, we return true. Right. So this is the output of our question or example taken. So I hope you understood this dry run. And suppose let's take one more case. Let's suppose there was 8 with count 1. Just take it. Okay. So what happens? Here we will be having length 5 in dictionary, but set will be same, right? Because 1 comes again, so it gets entered here, so it gets ignored, right? So they are not equal, so we return false. Fine. So I hope you understood the dry run. If you have any doubt or confusion about the solution we arrived at and how we arrived at it, I will suggest going back and understanding the intuition and set along with dictionary data structure, then the approach and the code. After that, do a dry run by yourself on 2, 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since you're familiar with the problem and the solution, let's move to the lead code and code the solution. Declare a map or with its dictionary. Great. And we will iterate for val in array. If val is present in map, then what we do? Map of val, we increment the count. Else if it is not present, then we will just add the value and keep the count as 1. Fine. So this is done. We have taken the frequency of every value in the array. Now we declare a set. Okay, we will iterate for key value in map.items. Fine. We will do set dot add the value. Since we need the frequencies also only to be unique, right? So we won't be adding the key. Please keep that in mind. We will just be adding the values, the frequencies. That is done here, and at the end we return set if it is equals to length of set if this is equals to length of map. Let's submit the solution. It got accepted. Now let's finally submit it. Okay, our code got submitted successfully. Now, code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.